Okay, so now we have to understand another concept in OpenShift about OC debug node and how to expose the applications from cluster. In this video, we will discuss these two topics. So OC debug node is a command that we can use to jump on our worker and master node. So OC get nodes, we have nodes. So I can use OC debug node/node name. It will run a pod on OC debug node. For example, I want to debug this node and press enter. So what happened actually, this command ran a very high privilege container on this worker node and automatically connect our terminal with this with that pod. And now we are inside that pod, and that pod can with the high privileges can mount the host machine file system. If I do df-h, so here you can see the slash host. Under the slash host, everything is mounted under the slash host directory. So it's mean the slash host we can declare as chroot, and it is recommending us to use this command to switch to change our root to slash host. Now we can run any command from on this pod to access our worker node, because its file system become the root file system of this container. So if I type anything IPA, so you can see this is the IP of my worker node. This is the interface of my worker node. This is the these are all the interfaces on my worker node. I can show you etc host. So this is the etc host file and host name. So we are actually working on our worker node. So you don't need to do SSH to worker and master node. You can use this command even if you don't know the password of even if you don't have the SSH key of this core OS that is actually running on the worker and master nodes. So with this pod we can debug, we can directly enter into our nodes and we can trace anything on the OS level we want to debug anything. So now I just open another terminal, and here if I run command occat pod -a grep debug with the name debug, there will be a container, yes. So it create a dummy project OpenShift debug this random namespace, this random project name, and this is the name of the pod. So if I get occat pod, this is pod name, this is the namespace. So you can see this pod is running on this worker node, and if I do a describe, so here you can see the image of this. This is a special image uh, designed by Red Hat to make connectivity with the OS level. And here you can see the whatever is mounted. The slash host from host is mounted. So that's why we can connect with this our worker node. If I do exit from this pod, so this pod that just ran is gone, and that namespace is also removed. So this will be created on the runtime just to have some debug on the worker, any worker and master node. So use this method to jump into our physical infrastructure on the cluster for any type of debugging. Okay, so next thing we have to understand how to expose the application from cluster. So far, what we understand about this architecture we have, that we are using this OpenShift net to connect all the OpenShift worker and master node, and it is connected with this load balancer interface to get the DHCP, DNS, internet, NFS share, everything is there. And there is ingress controller, a reverse proxy is running uh, that is responsible to expose the HTTP and HTTPS based application, the web based applications. So whenever we are making any route, it is able to expose from OpenShift the web based applications only. But think about if we have some application that is not web based. For example, it's some different protocol, it's some SSH, or it is something like we can say uh, the connectivity with some database. Okay, so that traffic is not HTTPS based. That traffic is not manageable by reverse proxy by the routes. For that purpose, we will use the concept of NodePort. So all these concepts about the services, how many type of services we have, are discussed in detail in our Kubernetes deep dive section. If you are confused with the services concept, just look into the some videos that are we did in very detail to understand the node port, the load balancer type of service, the cluster IP type of service, and the headless service. So everything is discussed in detail. So here we want to expose another type of application, that is database. So I will run a database application on the cluster, and I will expose that application by using the node and the node port. So for that reason, what I will do, I am going to use this command. So this command will create a new app with this name MariaDB, and with the new app you can use -e switch to pass the environment variable, just same like we can use when we run straightforward a pod, and we can provide the environment variable. So these environment variables, are mandatory to run the MySQL database or any database in the form of container. So I provide this root password, the MariaDB database, it will create this user, it will create the password of this user, and it will use this MariaDB image. Let me just run this command. And why I am using new app? Because it will automatically create the deployment and the service. So we don't need to worry about writing the manifest or anything. So right now I am logging with my kubeadmin user. So now this you can see this MariaDB is created and application is exposed, and OC status we can see it is working. OC get pod, yes, MariaDB pod is up 16 seconds ago, and OC get SVC, yeah, MariaDB service cluster IP type is created, and this cluster IP is only reachable from within the cluster. But we are discussing that how we can expose this database outside the cluster, because definitely developers need to access this database for the patching purpose, for different reasons it can be. So we have to expose this, but I cannot expose this by using the route, because this is not a web-based traffic, it's a database port. So what I can do, OC edit SVC, the name of the service, And what I will do, I just need to change the type from cluster IP to NodePort. And NodePort will expose a new port on all master and worker nodes to reach to this cluster IP. Okay, so this 31060 port is now reachable on all my master and worker nodes. Let me just to verify telnet 10.10.10.201 is the IP of my master node, and just telnet this port, you can see it's reachable. So my worker node, this is my first one, it's reachable. So it is reachable across the whole cluster. So now I can connect with this database by using this port from either by any of the master and worker node. But in this diagram, we are not able to connect directly with any master and worker node. There is a load balancer in between this OpenShift cluster. So we need to make another rule in HA proxy that will route the database traffic from this WAN public facing interface to inside the cluster. And we know the port number that is running on all master and worker nodes. And we will use that port to expose in our HA proxy. So we just need to 31060 port, and we have to make a new rule in our etc HA proxy.cfg. So here is the ingress for port 443. So what I will do, just I will copy this whole another and I will type here, for example, I can say devdb front end, and here devdb backend. Okay, and here I have to provide the backend default, that is devdb, and the port outside that will try to connect is 3306. I can use any port, but I will use a default port because I don't want to confuse my developers. And this 443 will be replaced by the port 31061. So on master node, this port is open, master node 2. Okay, so any master whenever the external request will come on the load balancer, it will be distributed on any of the master node uh, to do the load balancing. Now I will save this. I need to do a systemctl restart HA proxy, and from the browser, we 1.2.3.50 So here db devdb front end and back end is added, and you can see all are green. Okay, it's mean all the master and worker node are able to receive traffic on the port we defined in the HA proxy. So from here you can also see the health of ports, whatever you expose as a node. Now I know what username and password I define. I define the root password as 123 ABC, and I create this database. So let me try to connect with this database from my machine. So I have this Navigat application. I will use this NaviCat to connect with this database from the load balancer public interface, this interface. So I am here cluster as a cluster admin or developer. I have this application NaviCat on this machine, and this machine, is connected with WAN net, and I will hit 12350 IP to connect with my database. So connection MySQL, I don't want to create a new connection name. I can say OpenShift DB dev, because I created this in dev namespace, and the IP I will use 12350, the public IP, the root, and the password I have 123 ABC. I just test the connection. Perfect. Connection successful. It's mean the traffic goes routed to this interface, and HA proxy sends the port and forward to any of the master and worker node, and that reach successfully to our pod by the uh, CNI, container network interfacing. So it's connected. Let me double click this. Okay, we can see all these databases. My database we created, here in this command we use database name my database. It is created. So this user is also created. Either I can use this user to connect with this database. So this database accessibility is working fine. Sorry, where is the, yeah. So here we can see there is no table, but in the MySQL these are all the tables. And for example, let me open this TB table. You can see this my user has full access on DB database. Okay, so we have uh, we did a successful testing of exposing a known HTTP based application outside the cluster using the NodePort, and we fine-tune our HA proxy. So far we understand two type of concept of exposing application. One is by route using ingress controller, that is working as a reverse proxy, and reverse proxy tendency is only to take care of HTTP based traffic. So any other port we want to expose other than HTTP, we must have to use NodePort. Now, uh, one more concept is related to exposing the application directly from the cluster. There can be a situation, mean sometime the CNI used by the cluster, Kubernetes cluster, is not able to provide the high throughput to the application, because if you look in this architecture, here you can see all master and worker node have only one interface, and on this one interface is interacting with the cluster internal services as well as the application we are going to host. So only this one interface is responsible to tackle all the traffic. But there can be a situation where you want a very high bandwidth and you want to expose some application directly with some interface. For example, I attach one more interface here with my worker node 1. Okay, now I want to run here a pod that will be connected with the CNI cluster. We built in IP allocation mechanism inside the cluster, as well as with this new interface, dedicated interface. So for this reason, we can use the concept of network attachment definition. So in in OpenShift, OC API resources, and if I just grab network, so yeah, here you can see network attachment definitions. So this is a custom resource created by OpenShift. It is not by default available in the Kubernetes. So OpenShift designed this special network attachment definition resource that can help us to directly attach some pod with some physical interface available on any worker on or master node, any node on the cluster, wherever we want to run that pod. So for this reason, what I did, I add a new interface with this worker node, and I connect this interface. Let me just change the color to blue with this WAN net directly. It's mean this worker node now has two interfaces. One is that is normally working with the OpenShift network, and another network interface that is directly connected with the WAN net. And you know, on the WAN net IP scheme is 1.2.3.0/24. So I allocate an IP here from the series of 1.2.3. I believe 150. Yeah, 150. I allocate it on this interface. On this interface, I allocate this IP. It means this worker node is directly reachable from this WAN net, and I can ping this IP from my load balancer. So let me just ping this IP to make sure either this is reachable. 1.2.3.150. Okay, perfect. This is reachable. So now I will do OC debug, OC get nodes, OC debug node, this worker node 1, because I attach the interface on this worker node 1. Let me switch to chroot, and here IPA pipe sign more. Just I am going to minimize the font size, and here you can see this is the interface that is connected directly with this interface for OpenShift net, and this second interface is ENS224, and its IP is directly allocated on this interface. Okay, so this interface IP is allocated now. I showed you this ENS224 interface. So now we have to make some modification. We have to create a resource that will be based on network attachment definition, and this resource will guide our CNI used by OpenShift cluster, and that CNI is basically OC projects grep multus. Yeah, this is OpenShift multus namespace. OC get pod hyphen o white in the namespace OpenShift multus. So here, this is the CNI of our OpenShift cluster, same like ViewNet we used and Calico we used on Kubernetes. So Red Hat is using this CNI, and you can see on worker node 2 this is running, and it's a daemon set running on all the worker and master node. And just minimize the font size. This is on worker node 2. this is on worker node 1, and these three are on control plane. Okay, and they are responsible to make the complete communication among the pod across the cluster, allocation of IP, everything. So this multus is using this network attachment definition, and I will create a manifest of kind network attachment definition. Name I set to directnet, and here CNI variant whatever we are using I defined multis, and type, there are different types I can use, but I use the host device. Any available host network device we can, I want to define in this custom resource definition. Its name is this directnet, any name you can give, what device that is spare on your machine, and it will be used to connect with this custom resource definition, network attachment definition. And IP address allocation method, IPAM, I use static because this is the IP on my network interface. And the gateway is not mandatory because gateway will also be allocated to the pod that will use this interface from the CNI side. So I should remove this gateway. Okay, so this will add a new definition in the CNI to use this interface too. So let me just create this manifest. So network attachment definition .yml, and here okay, this interface will be used, and this is the name. IP address is static. We can use here type DHCP if this network is having some DHCP running on the backend. Then it will automatically get IP from the DHCP. But we have used the static, and okay, everything good. Let me just save this and apply. So this is created. So OCCAT network attachment definition. Uh, this full name. Yeah, net attached def, we can say. So this is created with the name directnet, and you can also do describe definition directnet. So here you can see type and everything, the network interface defined. Now I will create a pod that will use a direct link, direct net link. I can use deployment, so I will use the pod. So this pod is actually having this annotation, and in this annotation this network attachment definition name is defined, and this pod will try to use this definition and will try to lock this network interface within the pod. So let me apply this. So I put the name as NetPod or multus-pod. I can see NetworkAttachmentDefinition. And this annotation will use this resource. We'll define this resource for this pod, and the image that I use, HTTPD, any image you can use, and it's my container. Name is my container, any name you can define. So let me apply this. Pod. You can see this pod is trying to create, but one mistake I did, I think, hyphen o white. Fortunately, this pod is created on worker node 1. If this will create on worker node 2, it will give the error because worker node 2 don't have the network interface we define in our NAD. So we must have to define, yes, I defined the node name so that it will only be allocated to this worker node. So whatever network interface you define in your NAD, that should be we must have to define that node name so that this pod will only go to that specific node, then it will be able to use that interface. So for example, if I deploy this to wrong uh, machine, let me oc get pod, oc delete pod, net pod, and oc apply again. So it's created, and now you will see it will not run. So if I do, because it's on worker node 2 and worker node 2 does not contain any network interface we define in our net. So OC describe pod net pod. So here you can see it is giving error. Adding container to a network direct net failed to find host device link because that device is not available on the worker node 2, it's available on worker node 1. So I will delete and I will add it back to worker node 1, and then I will apply this time it will be created, and now if I jump into this pod, and this is Apache 2 IPA command is not available. Let me install this IP command on this node. So it's Debian based. So apt update. Okay, so we updated. We have to install IP route 2 package to provide the IP command. So now if I run IPA, you can see this network interface from the CNI, and this network interface is directly attached with this pod, and this pod got the IP from that interface that we link. And if I go to my browser and I try to directly hit this IP, you can see I from my machine I can directly connect with this interface to access the service on the pod. So with this way, this can be a situation where you want to expose some high traffic application out to the cluster directly with some network. You can use any network IP, and that network will be able to reach that pod directly inside the cluster. So you can bypass this load balancer, everything. And one more thing, right now this pod is using this interface. I will again go back to OC nodes, OC debug node, and here when I will run IPA pipe sign more, you can see the second interface is gone, is no more available. Now that second interface ENS that I added is not listed here. But previously when I came here to ask, because that interface is now directly attached with the pod. Even this base machine, host machine is not able to use that interface. And no other pod even can use that interface. So this interface is dedicatedly attached with this pod. So when I will stop this pod, let me see get pod. So NetPod, I am running OC delete pod, and now when I will run IPA command, so you can see this interface is back to the operating system. Now any other pod can use this. So this was the concept of directly exposing the application with some dedicated link, and this link can be of any speed, whatever you can define. It's depend on your requirement, what bandwidth you need. Actually, when I will now do refresh, it will give me the error because this is directly landing now on the host machine, not inside the pod. So this was the concept of exposing application. So we understand three methods of exposing application: by ingress controller using the route, that is the web-based traffic, using reverse proxy. Second is NodePort, and third, directly connect pod with dedicated network using network attachment definition, custom resource created by the OpenShift for this purpose.